Hi, I'm Raj Singh. I'm a developer advocate with IBM Cloud and Watson platform. So my job as a developer advocate is to help make people like you more productive on the IBM Cloud. But I haven't been doing this that long. I've mainly been a geospatial professional for 20 years. And so bringing what I'm going to show you today, mapping to the data science platform, means a lot to me. I'm very excited about bringing some of this stuff that's been sort of locked in the world of GIS and geospatial analytics to the larger mainstream analytics world. So, you know, I spent a lot of time actually at MIT in the 90s doing, before it was called data science, spent a lot of time in grad school working with census data, which at the time was really large data. We had to wait till like midnight when the US government server, FTP servers weren't too busy and download big census data files and then put them somewhere and use them and do some analytics on them and then make maps by hand. And then luckily the census data only changes every 10 years, so it wasn't a big deal. But you know, that kind of gave me the first flavor of how monotonous and redundant and a lot of our work is until we get to the real payoff, which is actually studying some topic, doing some analysis, tackling some real problem. So it's really exciting to see at this conference and at a lot of, you know, I was at PyData a few weeks ago, and this is the logical progression into more specialization in Jupyter, but everybody's moving to awesome analytics on cloud platforms. So my talk is about Jupyter, which everybody here obviously knows well. Pixiedust, my colleague David Taeb gave a presentation on a lot of the non-spatial visualization pieces of it this morning, and I hope you saw us at the booth. And my thing is on maps. So I'm going to start here. So I love this quote. This has stuck with me for a couple years, and this is about over 10 years old now, but I love this. Good programmers are lazy and dumb, because a lot of the motivation of programming came out of not wanting to repeatedly write the same code over and over again. And first of all, we don't want to do that because we're lazy. But second of all, we don't want to write monotonous, repetitive code because it introduces errors. And finally, if people are working on libraries have been around for decades, right? People work on libraries together and continually improve those libraries. Everything speeds up. Everybody, you know, nobody writes on Unix, nobody writes sockets and threading anymore. You just grab a library and it works really well, better than you could write yourself. So that's part of the motivation behind Pixiedust. There's nothing magical here. It's the automation of code that you could have written by hand, but now is packaged up in a library, which everybody can contribute to and improve. So actually, before I go on to this, I want to ask a few questions. Who in the audience would consider themselves a statistician? A few. Who considers themselves a data scientist? Good, because people aren't lying. How many people understand, really feel like they understand what a data scientist's job is? And I'm keeping my hand down for a reason. So how many people are, there's probably few, how many people are web developers here? Okay, so what are the rest of you? And finally, how many people have done a lot of mapping in their job? Okay. So some people didn't raise their hands at all, and my final question when I give this presentation is, who feels like they have to do a little bit of all this stuff in their job to be successful? Yes. And so more of a reason why we need to use libraries, right? And not spend a lot of time repeating not only monotonous code, but this stuff is hard to keep in your head. If you're anything like me, I probably spend more than half my time looking up the little details of a command. Like I know basically the command I want to use, but I don't know all the details of the parameters to get the same thing I got last week. And that occurs through all kinds of different facets of what we have to do, like the sexy stuff that our bosses want us to talk about or produce is a visualization, use Spark, and build the analyses in notebooks and throw some machine learning in there. But to be able to do all that stuff, we have to know all this. Linear regression is really a statistician's expertise. Analysis of errors, analysis of variation, data cleansing. You have some data engineering jobs in here. You've got a lot of the data science stuff at the top, and you have a lot of database administrator stuff in here. And it all kind of has to come together in this thing we call data science. So, which kind of sucks for us. So, and then what we're able to get out of this in the end isn't that great. If you're building a matplotlib chart, this is like 11, it's not too bad, maybe about 10 lines of code. I never remember what the exact X and Y label code is, so I'll spend some time looking that up, finally get it out, and at the end of it, find some old notebook you did that has the code, and after you spend half an hour finding that, then you put this together, and then that's not that great a chart, is it? Kind of ugly. And in mapping, it's even worse. So to make this thing, which looks like something out of like Ms. Pac-Man, you have to write 20, 30 lines of code, and Matplotlib does have a mapping library available, but it doesn't do much of a great job. What we really want is something Google Maps kind of sets the bar on. This is a Mapbox map, which is a partner of ours, but that is a lot more what you want. You can zoom into that, and you get more, more place names surfacing. As you zoom in, you get more detail on the underlying contextual geography. You can still see your data. That's really what you want. So, and that's what Pixiedust will give you. So basically, if you haven't seen the demo in the booth yet, you get yourself a DataFrame in Python or PySpark DataFrames, Spark DataFrame, and you just call the display command, which is a Pixiedust command, which pops up a dialog box. Actually, it pops up a menu, and you choose from whether you want a bar chart, line chart, all these things. If you pick map, you have to pick what your latitude, longitude columns are, the numeric variable you want to map, and that's all you have to do. And then it generates a lot of Python to translate your data frame into a geographic JSON object. Then a lot of JavaScript to create the right shadings and colorings of your data, and legends, and puts it in about 2 seconds, puts it all in your notebook. And I'll just throw this in, and that's really what makes what we try to do in comparison to our competitors, Azure and AWS. We try to make this data simple and accessible to more than just the deep hardcore programmer. This is my boss, Derek, and he's been telling me this for 3 years. So I'm going to quickly, before I go into the mapping demo, it's going to be about 20 minutes of demo, so sit through a quick little overview of all the things Pixiedust does. So I'm focusing on visualizations, but we also have package management, cloud integration, Scala Bridge, extensibility, and embedded apps in here. So first, package manager. If you've done a lot of Jupyter work, you need to use your own custom jar file. Thought I'd taken out this transition. You need to use your own custom jar file. You have to shut down, install the jar file, change your configuration file, and then restart again, if you know how to do that in the first place. Pixiedust allows you to just run a command, Pixiedust install package, and grab the jar. And without restarting or anything, you may have to restart your kernel from the menu, but at least you don't have to leave your Jupyter Notebook environment to just start going. Visualizations, other than mapping, we have the bar chart, line chart, scatter plot, pie chart, and histogram. Cloud integration. Sometimes it's hard, or sometimes you have to look up too many commands to be able to actually download data. And downloading data is probably something people know pretty well, but instead of downloading data, getting it off into a database, getting your results into a database is something very esoteric and very hand-coded. So, we're a commercial organization. Although Pixiedust is open source, we focus on building adapters to stash your data into our databases of choice. So right now we have cloud and object storage, which is IBM's sort of competitor to S3, and then text download format, CSV, XML, JSON, plain text, HTML, Markdown. And we would love pull requests and community contributions to extend that list of database stashing to a lot more platforms. Scala Bridge, some people I know Scala, so I've never used this. But for people who do use Scala, and one big problem with Scala is that it has a lot of benefits, but it has horrible visualization libraries. You can share, this allows you to share variables with Scala, so you can send Scala a variable, perhaps a data frame, do some work on it in Scala, get it back into the Python environment, and then use all the Python visualization, including Pixiedust, all the Python-based visualization libraries like Matplotlib and etc. Extensibility, well, I won't talk a lot about this. You can, if you're a really good programmer, you can extend all the visualizations. But we also, after doing that, we created a lighter weight way to extend Pixiedust, which is basically using Jinja 2 templating, writing a little HTML and CSS to build basically dashboards like you might do in Tableau, but Tableau is, you get what they give you. Here you can do whatever you want. And David Taeb can talk a lot about extending Pixiedust with HTML. So let's talk about mapping and get out of PowerPoint. Okay, so I'm going to go back to the beginning. This is IBM's data science experience, which does a few things, but the flagship part of it right now is Jupyter Notebooks on the cloud with Spark built in. So you can have a project library and share your Jupyter-based projects with collaborators. I'm going to go into this folder I have, and I'm going to find my mapping overview. And fire up this notebook. So Pixiedust is an open source library, publicly available on PyPy and GitHub, and it will run in your standalone Jupyter notebooks, but it will also run on our cloud-hosted version of Jupyter. So I'm just going to go through, So in a multi-collaborator setting, sometimes it can be locked so you don't step on somebody else's edits, so I have to go into edit mode here. And I'm basically just going to start running a notebook to show you how quick this and how code-free this works. So right now what we're doing, what's taking so long is it's firing up, this is a multi-user cloud environment, so it's provisioning you the Jupyter kernel, provisioning you actually starting up your Spark instance. You've already provisioned it. And getting going here. This looks like slow internet more than anything. I have a local version of this if I need to go to it. Switch over local version for now, which is proof that it's exactly the same code, I guess. Let me restart the kernel so you know this is for real. So I commented out my pip install because I don't need that more than once. So we just import three basic things: pandas, NumPy, and Pixiedust. David's released a new version since I built this, and I don't want to use it. So, oops, sorry. So all I'm going to do here is, I do a lot of work with open data too, so I'm going to pull in a open data set from the city of Boston. This is all the property appraisal data from 2016. It's about 100,000 parcels in Boston, so not a huge data set. And all I want about 10 of the different columns. I need the latitude and longitude because I want to map this stuff. And I grab the land use, property type, owner occupancy, things like that. Then I just do some quick little things like make sure I'm not going to use the rows where latitude or longitude is null. And then I'm going to call this prop display command, the Pixiedust display command, on a sample of 30 rows from the properties just to make sure the data looks good. So I'm really having a problem with the internet here because it stopped at this request to grab the data. Oh, nice Ethernet. Cross your fingers. All right, we are in business. So Pixiedust, if you just looking at a table view of your data, if you ever use Python print is not the nicest way to see your data. Pixiedust quickly gives you the schema in a drop down. Not too much formatting of it yet. You can see the data types for all your columns. And I asked for a sample of 30. So I just see that here in a nice scrollable table. That's not too exciting because we're not doing mapping yet. So once more, get rid of some bad data. I'm just going to grab properties where the living area is greater than 0. So I don't want little tiny slivers of data or badly coded data. And then we'll run that display command again. But this time, we've chosen the map command. And you'll see those 100,000 points pop in real time. So what I did here before the demo was I pre-filled these things. Latitude and longitude are my keys, and living area is the value I want to look at. So this is showing me the living area of properties in Boston by square footage. So purple, you can see your higher values, orange are lower values. And just visually, you can see a lot of, start to see a lot of patterns, which is really important. And when you're first working on any kind of data science project, what you're doing is really a lot of exploratory data analysis, trying to figure out what's going on with your data before you start to move to a stage where you produce your final presentations and reports and visualizations. So, and that's exactly the time where you don't want to be bogged down in code documentation, looking up commands, because that is context switching and taking yourself away from actually trying to solve your problem. So, most developer productivity is lost in context switching. And so if you fire up a web browser to go look up pandas documentation, then maybe, oh, I'm in a web browser, maybe I'll go to a tab and open up Amazon and do a little shopping I forgot to do or something like that. There are a lot of productivity losses in context switching. So I can stay here, maybe orange to purple isn't showing me the right thing. I'll switch my color ramp to light to dark red. That makes more sense for a continuous value. So we'll see, we can, we're just looking at living area. We see down here, oh, those are low square footage areas. That makes sense, because I know Boston, these are more spread out single family homes. As you get towards the core of the city up here, these are more high rises. But still, I'm a little surprised because, you know, we're going up to over, what's this, 1.9 million square feet. That doesn't sound like residential. So I had in my mind I was going to look at residential. Oh, but, so that must mean these were probably office buildings, right? So let's take a look at the data. Let's bar chart the data by land use type. So you have to go look at the city of Boston's land use coding chart, excuse me, to know what these mean, but R1, R2, R3, and R4 are the residential codes. R1 is single family, R4 is four family and above. But we have all these other, which are actually the highest values for square footage. E is tax exempt, C is commercial, then we have RC, residential commercial mix. So all those are really not helping me with my look at residential square footage. So then we can quickly, and I made that, once again, I'll show you the options. I made that with absolutely no code. Just said, okay, my key value here is land use, and I want to aggregate living area, take the average living area for each row, and group it up by land use code. Oh, and here, this is important. So Pixiedust works on a sample of your data, so I'm going to use 10,000 values here. And once more, this is really helpful for the exploratory data analysis stage. As you move towards, you know, actually producing your results, you'll want to use the full data set, or more and more of it. But this gives me this tells me what I need to know here, which is I have to get rid of all these land use codes which are not relevant to what I'm doing. And I can look a little deeper into that, show me just the the land use codes which have square footage values greater than 3,000 square feet. So some R1, some single family residentials are bigger than that. But mostly these are all these other codes. So I'm on the right track here. We need R1 through R4. So res living, I'll make a new data frame. Just give me R1, R2, R3, and R4. And if we map those now, now we get something that's beginning to look a little better. Oop. So this, once again, is downtown Boston, Back Bay. Fenway Park is right there. So we still have the purple, the highest values here, which are probably those multifamily apartment buildings. You zoom out, actually, sorry, not values. Chelsea area out by the airport, down here in the more single-family residential area is lower, which makes sense. And so finally, we go down here and we get values per square foot. So I divide the total square footage of each property by the total housing value. And we get a map which really makes sense as somebody who's looking at residential property values in Boston. So per square foot, the highest values are here in purple. Downtown, the nicest residential areas will go to Beacon Hill over here. This is all residential. This is where John Kerry lives, if you remember when he ran for president. I don't know if New Yorkers remember John Kerry so much. And then we'll come down here. Here's some of the more, you know, the public housing projects area and some of the poor areas. And then values go up down here where we have some of the nicer, you know, it's still an urban area, but these are a lot of single family homes and double deckers over here with better neighborhoods, better schools. And then you move over here, over by the airport, and once more you get down to the lower values. airports cause lower housing values. So that's, I put this whole thing together in 2 or 3 hours because I didn't have to write any code. And now I'm going to get into a couple little more advanced things and then talk about how everything works. So that was basically point mapping. I had a latitude and a longitude field in my data, so I could map points on I could put points on a map. We also support lines and polygons, and a lot of people who aren't in the natural resources space or military don't ever understand why you'd need to map lines or polygons, because usually you're mapping customers or something like that. But in this case, this is actually health data, and a lot of the sample health data you get, we do a lot of work in health with Watson Health. A lot of the sample health data you get is aggregated to the 3-digit zip code level to maintain privacy for those people. So we had to come up with a 3-digit zip code map. So took the 5-digit zip codes from the government, dissolved the polygons down to the 3-digit level, which was an exercise in and of itself. But once we had that data set, we could build it into Pixiedust, and then we took some data from one of our health studies, and we didn't have any geometric data for it, but we had this 3-digit zip code. And then we were able to map it. Now, I'm not using that data here because we're not allowed to share it publicly, but I just have population value for that 3-digit zip code, and we can map that. So what this function does here is take my data frame that has a zip code in it, join it to the geometry file that we have publicly available, and then we have these polygon objects, which are in a standard format called GeoJSON, and that allows us to map this in Pixiedust. So we have the same map, we have great interactivity, you can hover over and see the population of whatever value we're mapping, pops up there. And you'll see here there are holes in the data because, once again, I'm only displaying 1,000 rows. Let's try to display more. There we go. So now you see the whole country. That was my mistake. But see how fast that was? Just a second to fix the problem with my data. So that's nice. And once again, if you're printing, if you want to print, you want to go black and white, or you have accessibility issue, you can go black and white. And you've done you probably don't know how to do this because your job isn't mapping, so you've been able to take advantage of, you might need an hour to train on that instead of weeks that it would take to understand all the JavaScript that's grabbing this. I should mention that I'm going to go up to this map because it's easier to show. So this is, okay, thanks. This is a very interactive map, and it takes a lot of JavaScript to make this happen. And also, as I zoom in, you see these names come in. This is also a lot of functionality we take for granted. We expect this to be there, but it takes a lot of processing power for Google to be shipping out those tiles all the time in your street map and all that stuff. And switch here to another kind of map. Let's go with satellite, just so you can see. So we didn't build this all ourselves. We partnered with a great company called Mapbox, which does this for a living, provides these base maps. See, I zoom in, get more detail. I can go right down to a building and go over to my data. So if I go over to an area with my data in it, I just have the opacity set very light. So once I zoom down this far, it's hard to see my point, so I'll bump the opacity up. I wish nobody would say that. Good question. We haven't figured out a good way to, we haven't focused on that little nice usability tweak. I think it's possible. But so if you really, so we're looking at a housing study here. If you wanted really doing a residential study, you switch to the satellite imagery and you zoom in and you get a better idea of what those places really look like on the ground. But that takes a lot of work. Like doing this yourself would not just take a lot of JavaScript programming, but it's nice to have a company behind that base mapping piece, which does it well, does it, as their primary business goal. I'm going to switch back to dark because data often looks better on a simpler map. Yeah, and you still get all that wonderful context of knowing where a place is when you're looking at geographic data. And I'm going to switch over. I'm going to try to go back to DSX so I can show you that our platform really works now that we have internet. And I'm going to show you one more thing, which is, so you may have missed this, but I said Pixiedust is all handles data in memory. So that's why we're just taking a sample of the data. Now there's a problem if I get off full screen. Now one problem is if your data doesn't fit in memory, what do you do? And that's a big problem with geographic data because, oh, that's the wrong one. Am I in publication or vanity net? So one thing people who don't understand geographic data take for granted is that something like the zip code boundaries can be huge. A shoreline boundary can be millions and millions of points to get the detail you want. Zip codes, that's a natural thing, so that's not as important to a business analysis, but a zip code boundary can be thousands of points to describe it properly. And that's not even, that's just the geometry of it. That's not talking about your data. So if you have to bring that into memory all the time and you have to map thousands and thousands of zip codes, that's a problem. Or if you have to map millions of data points. So this is a study which I'm not going to talk about too much. I have a blog on it, which is there. But this Mapbox has a way to take a data set that's too large that you don't want to fit in memory, send it to their server, they tile the whole thing up. Tile is a format, is a quick term we call for building different levels of detail of the data set so that as you move around in your map, you only send the data to the user that they need. So I just did an analysis, we don't see it here, but I did an analysis of which areas in the country are most urban based on zip codes. And there's thousands of zip codes in the country. And if I had all that zip code data in the browser, plus all my numeric data, it would blow up. But this way, using Mapbox's tiling scheme and calling on it from within Pixiedust, I can see the whole, I can zoom around the country in a matter of milliseconds. So you'll see the country in general is a pretty rural place. But as you zoom in, you'll get more detail. And Mapbox, if I zoom in fast enough, you'll see tiles here. Let me try to. See, they're so good you can't even see the tile. Sometimes you'll see a square, which is blank because the tile of data hasn't loaded in yet. But Mapbox, for every, like this picture is probably about 20 tiles. It'll bring in every tile of data asynchronously, so user has no slowdown. And then take every tile of data and apply your styling rules to it. So what I'm doing here in JavaScript is saying, okay, I have like 10,000 zip codes. As you bring in data, find me the zip code. Like I have data for this zip code. Find me that zip code. Apply this color to it. Look up this color and apply it and show it on the map. And all that's happening fast enough so that if you did analysis of the whole country, let's say you're looking at shoppers per square foot around shopping malls, you could provide a map which is seamlessly zoomable and doesn't slow down at all. Okay, so those are some demos. Glad I could show that data science experience works when the internet is on. I'm just going to wrap up in a couple minutes. So just to summarize what is going on the technology side, Pixiedust is a Python library which basically packages up a lot of redundant, boring, monotonous Python code, gives it to you in a menu system, nice widget-based menu system. In the mapping, we convert Spark or Pandas data frames to GeoJSON format, which our partner company Mapbox, which provides that JavaScript mapping library, can put on a map. We do some more Python to cut the data set into quantiles, and then we put those quantiles into another JavaScript file for styling, map styling. And that's basically all we do. And then we take that JavaScript we created and put it into a Jinja 2 template, which is what Pixiedust decided to use for creating interactive graphics on in Jupyter, which is basically a web application. So we do this. If you look through the Pixiedust code, you'll find all these pieces in these directories. And then we render, in the case of mapping, we render it in iframe. And then we call the Mapbox API for getting those base street maps. So in the future, going to add some more cartographic options. You saw me play around with some of the styling, some of the color ramps, the opacity of points and polygons. We have some work right now going on to add temporal visualization, which is going to be awesome, because a lot of things aren't just on the Earth, but they also move around the Earth, like clouds and weather and military features of interest. Mapbox liked what we did so much, they're building an official library for Jupyter, and we're going to use that in Pixiedust, and you'll be able to use it on your own as a Python developer. And then we're going to integrate more mapping providers, Esri, Carto, and some other things. And so Pixiedust on GitHub here, open source. You can try it on Data Science Experience and use it and join us in community of developers. Thanks.
Thank you. We have time for maybe one quick question. Yeah.
It looks like the local install of Pixiedust requires Spark 1.6.
This is a little bit old. It doesn't anymore. Quick answer. Yeah.
So following up on that, you could just pip, you can just pip Pixiedust and you're ready to go?
Yes. If you don't want to develop on the code, you can pip install Pixiedust and go.
Okay, so that's the end of today's sessions in this room. There's one more talk in several of the other rooms. So let's thank the speaker again.
Okay, thanks.